Okay, good morning, everybody. We are going to, the next couple of days, well, I guess the next week or so, we're going to be reviewing factoring. And you guys saw factoring at the end of Math 2. One of the things that I see in Math 3 is that I often have to review factoring because students aren't very good at it. So this is an extremely important concept. We use it all throughout Math 3 and all other math classes from here on out. And I'm going to go back to the basics because I want to make sure that you totally get it. This is not a topic where you kind of get it. So remember, like, our goal in this class is not to rush through anything, but to make sure it makes 100% sense. Okay, so as I go through, you might have to pause the video every now and then to catch up with the notes, or maybe you have to go back and redo something. Okay, so we're going to start with kind of going back all the way to like 3rd and 4th grade, because that is a key for test taking strategy. So those of you who know that you are not good test takers, I'll tell you that one of the things that happens is that students don't relate their old learning to their new learning, or should I say their new learning to their old learning, and then they make everything brand new in their brain, and you get overloaded. If you can always go, oh, this is just like what I've already done, it's easier to remember it. Okay, so sometime in 3rd grade, we talked about factors. Now, you might remember that we said, oh, it goes in evenly. Okay, so I want you just to think about, trip down memory lane, that we know that 2 goes into 10 evenly and has a remainder of 0. Now, yes, I know you guys can do this, but this is huge that you can remember this very basic fact, that if something's a factor, there's no remainder. Remember when I talked about that we're going to do long division with algebra? It's going to be doing this exact thing, checking to see if there's a remainder or not. So if you can just remember the basics, that something's a factor if it divides in and has a remainder of 0. 2's not a factor of 11 because it has a remainder of 1. That's huge. Okay? Okay, now, then we moved up to 4th grade, and we said, what are factors of 18? Or something like this. This was a type of problem that you got. And again, this is going to be important because eventually we'll have algebra and we'll say, well, what are the factors of this algebraic expression? Okay, so we all might have learned it different ways, but you might have said, well, I know 1 and 18, and I know there's 2 and 9, and I know there's 3 and 6. Now, kids always tell me that they remember learning some kind of rainbow method. I don't know. We'll see if this rings a bell for you. So they learned like 3 times 6, 2 times 9, 1 times 18. But these numbers right here are all factors of 18. Okay, so that's something that you know, but you might not have thought about it a while. Okay, got to 5th grade, and we said, what is the prime factorization of 18? Okay, so we have to go back and think about prime numbers. Okay, and what you want to remember about prime numbers is that they have exactly 2 factors. And I really want to look at this definition because most people get it wrong. Okay, so it has to have exactly 2. So most people, when I say, okay, what's the first prime number? They say 1. 1 is not a prime number. It has only one factor, the number 1. So keep this in mind, exactly 2 factors. The first prime number is 2. Okay, and a lot of people miss that because they don't think even numbers are prime. Okay, and then we know 3, and we kind of think about these as that nothing else goes into them. Okay, then people start going, oh, they're just odd numbers, but they're not, because we know 9 has more factors than just 1 and 9. 10 won't work. 11 is prime. 13 is prime, but not 15, not 16, 17. Okay, and that would just keep on going forever. Okay, we're going to see that prime numbers have help us a lot in algebra. Okay, so now again, you might have learned this a little bit differently. Just kind of go with it. So the way I learned it is that you picked any two numbers that were factors. So I might have said 9 times 2. And then I learned to circle that because it was a prime number. 9, I had to factor some more. So I said this is 3 times 3. And those are both prime. So we said it's 2 times 3 times 3. Okay, so notice that's different than just listing the factors. Okay, so I want you to think about that. These are just the factors of 18. These are the prime factors of 18. So 2 times 3 is 6. 6 times 3 is 18. Okay, then we got really smart and we learned how to write it like that. Okay, so we found the prime factorization. That's what we do in algebra. We find the prime factors of an algebraic expression. Okay, so the first thing that we learned was how to find the greatest common factor. And we often called this the GCF. Okay, so you'll hear me talk about the GCF. Now, I'm going to show it to you one way, kind of weird, but I want you just to watch. Don't worry, I'm not going to make you do this. I would like you to put it into your notes, because I want you to see how it is just like this, even though it's algebra. Okay, so I would have looked at the 24, and I would have said, all right, I'm going to say 6 times 4, but neither of those are prime. So I'm going to do 3 times 2, both prime. 2 times 2, both prime. Okay, so I could say this is 2 cubed times 3. Okay, so I wrote out the prime factorization, but I have a variable in there. Okay, now let's do 32. Okay, so I might go 8 times 4. Neither of those are prime. 4 times 2, prime. Okay, those are prime. Phew, we got 1, 2, 3, 4, 5. So we've got 2 to the 5th times x to the 4th. Okay, so again, you're probably going, I don't think I did it that way. And you're right. But let's just look at how it works, because I want you to see that numbers and variables work the same way. This has 2 cubed, 2 to the 5th. The most they have in common is 2 cubed. Okay, that's the most. This one has a 3, this one doesn't. They don't have a 3 in common. We've got x cubed and x to the 4th. And the most they have in common is x cubed. So this is 8x cubed is the greatest common factor. Okay, so I'm not going to have you do it this way, but I kind of want you to see that, yeah, it is. It's just the same thing from the 5th grade. Okay, always link your memory. Okay, so I'm going to stop this video here because it's just getting long, and I'm going to add another one just because YouTube likes shorter videos, but it's going to be short. Okay.